Hey, howdy, hey, everybody. Today we're going to look at a review of synthetic division. I know this is something you've learned in the past, but we're just going to kind of go through the different possible examples and explain how they work just to refresh your memory and hopefully help you with homework. So here we go. Um, Here's the target, right? We're going to look at using synthetic division to find a quotient and remainder in polynomial division. That's a warm-up. We're going to skip that, and we'll jump right into the examples. All right, so in this problem, we want to divide 3x cubed minus 2x squared plus 3x minus 4 by x minus 3. And we're going to do that with synthetic division, but I want to sort of explain how synthetic division works, and in order to do that, we're going to start off by looking at it with regular old long division. And let me write it that way, and then we won't actually complete the entire problem with long division. I just want to make a point so that we can sort of see where the synthetic division algorithm comes from and why it works. But this is how we'd write it if we were doing this problem in long division. And what I want you to notice is that the first coefficient in the quotient is going to be produced by the number of times that the coefficient in the divisor here goes into the coefficient of the first term in the dividend, right? Synthetic division only works when the divisor is of the form x minus a. And that means that the coefficient of x has to be 1. Now, in this case, it is, right? And we'll get to problems where it's not and how we handle that. But the synthetic division algorithm works when the coefficient of x is 1, and it is here. So when that's the case, the first coefficient in the quotient is always going to be just the first coefficient in the dividend, if that makes sense, right? So how many times does x go into 3x cubed? 3x squared, right? So 3, okay, that 3 is simply going to be copied down, right? So 3x squared, and we do the multiplication, and we get 3x cubed minus 9x squared, and we can continue, right? But my point in showing you the long division is to make that point, right? That when the divisor is of the form x minus a, the first coefficient of the quotient is always the same as the first coefficient of the dividend, okay? All right, let's clear all that and do this with synthetic division, right? So in synthetic division, we've got our x minus a here, and we always put sort of the a value, and then we write the coefficients of the dividend, and we continue, right? So let's do that. You need to do this. So we'll do that here, right? So the a value is 3, not negative 3, right? Because we're talking about a divisor of the form x minus a. So a is simply the 3. And the coefficients in this case are 3, negative 2, 3, and negative 4. Okay? And we start by writing a 0 here. And the reason is of what I just said before, right? That when we have a divisor of the form x minus a and the coefficient of x is a 1, the first coefficient in the quotient, which we write underneath this line, is always just the first coefficient of the dividend, right? And what we do here is we add, right? And so the reason we're adding instead of subtracting like we do in long division is because we disregard the minus, right? So it becomes the opposite. So 3 plus 0 is 3, and that's always going to be the first coefficient in the dividend, right? So the first term in our quotient is going to have a coefficient of 3. All right, then to get here, we multiply, right? 3 times 3 is 9, right? Why are we doing that? Well, again, if we're looking at the long division form, and maybe I should just do that here along with this so that we can get a clear picture. 3x cubed minus 2x squared plus 3x. We'll stop there. This is 3x squared, right? We get 3x cubed minus 9x squared, right? So we can see this 9 is coming from the fact that we're multiplying the 3 by this 3. And that's what's happening here. We're multiplying the 3 by this 3, and we're getting 9. Now notice, in the long division version, we get a negative 9 because we're including the negative, whereas in the synthetic division version, we're just getting a positive 9 because the negative is sort of implied, if you will, I guess, right? We're just sort of handling that in a convenient way, kind of reversing our operations. So 3 times 3 is 9, negative 3 times 3 is negative 9. In long division, we do a subtraction, right? Negative 2 minus negative 9 is 7, okay? In synthetic division, because we have reversed the negative, if you will, we add instead of subtracting, right? So negative 2 plus 9 is positive 7. And so you can see we're getting the same result here, right? Again, because, let me pull down the x squared, because the coefficient of the x term in the divisor is 1, in order to get 7x squared, we multiply by 7. So whatever the coefficient here is in the x squared term is, that's going to be the next coefficient in the quotient, 7, right? And that's what we have here. So again, the quotient is sort of this bottom row, and this middle row is sort of the operation of the division and subtraction going on in the long division algorithm, right? Okay, 3 times 7 is 21. Negative 3 times 7 is negative 21. And we can see how this is proceeding. So 3 minus negative 21 is 24. 3 plus 21 is 24. Okay. 3 times 24 is 72. And negative 4 plus 72 is 68. Okay. And this is our remainder. Just like it would be if we continued this process up here, right? So our quotient is this guy, at least the coefficients of our quotient, right? We would need to translate that into the polynomial that is our quotient, right? So our quotient would be 3x squared plus 7x plus 24 with a remainder of 68. Okay, and that's our synthetic division algorithm, right? That's how that works. So that's a pretty simple example. We had a nice divisor here. It all worked out nicely, and we were able to get that answer. But hopefully you can see how synthetic division works, why that algorithm works as it relates to our friendly long division algorithm that we first learned. Okay, let's go to the next example. All right, so find the quotient and the remainder when that polynomial is divided by 2x minus 1. And you can see right off, this is not of the form that we wanted, right? This is of a different form. We've got a 2 here instead of a 1, and that is not good for the synthetic division algorithm. So what we need to do is make sure that we can get that to be a 1. And so what we do is we divide everything by 2. Right? Now that's a different divisor, but we'll handle that at the end, right? So this, we treat this as x minus 1/2, okay? We're basically factoring out the 2, realizing that, if we do this division, we can divide this by this divisor and then also by 2, right? And that will handle everything. So what we're going to do here is divide, instead of by 2x minus 1, we're going to divide by x minus 1/2, recognizing that that will produce a quotient that is twice as big as it should be, because we didn't divide out the 2, but it won't change the remainder. And if you want to just sort of see that by analogy, let's just take some numbers, right? Like, so imagine we wanted to divide, 22 by 10, right? So if I divide 22 by 10, then I know that that's, 2 with a remainder of 2, right? But let's say, I don't like dividing by 2-digit numbers because that's way too hard, right? So clearly I would rather divide by 5 because that's half of 10, right? So I'm going to divide by half of 10, and I'm going to get a quotient of 4. But my remainder is still going to be 2. Why? Because 2 was already less than half of the divisor I was originally dividing by. And so that remainder is going to be the same 2 that it was before. It's just that my quotient is twice as big as it should be, and I need to get the correct quotient, divide by the factor of 2 that I didn't divide by when I chose 5 instead of 10. So it's the same idea here. I don't like dividing by things that have a coefficient other than 1 here, so I'm going to divide out that coefficient from that divisor and factor it back in later in the quotient. But the remainder isn't going to be any different. So let's do the synthetic division with the 1/2. So we've got 1/2, 4, 4, minus 1, minus 6, 0, 4. 1/2 times 4 is 2. 4 plus 2 is 6. Half of 6 is 3. 3 plus -1 is 2. And half of 2 is 1. -6 plus 1 is -5. And so my remainder is -5. And because -5 is less than, if you will, right, it's of a smaller degree than my new divisor, that remainder isn't going to be any different than it would have been with my original divisor. And so I can recognize that this quotient, 4x squared plus 6x plus 2, is twice what it should be, right? So let's go back to the original formulation or original sort of equation of the chapter, which was that this is a quotient of x times a divisor, so let's say like 2x minus 1 plus a remainder. Okay, I'm saying let's change the divisor to be this, right? And realize that I haven't done the division by 2 here. I've associated the 2 still with the quotient, so in order to, I'm going to factor that 2 out and multiply it back now, right? So I need to factor out the quotient of 2 that's still associated with my quotient and put that back with my divisor, right? So the real quotient is 2x squared plus 3x plus 1 with a remainder of -5. That's the worst R ever. Okay. So those are the first 2 examples. I'll do another video with 2 more examples that are a little more complicated than this one, or these 2, and hopefully that will help you with all of the questions on the homework.